This video goes over the homework solution for a single factor analysis of variance from Chapter 11 and a chi-squared test for independence, Chapter 12. So the problem out of Chapter 11, they're giving you some data on display panels, and these are the time to remedy something. So it's a time measure based on the display panel. If you just look at the averages, it looks like the best one is B. The question is, because those are the averages, the X are the average time, and B is the best one because smaller the better. The question is it statistically different? So the first thing we do, because we have three populations, is we do an analysis of variance. So our null hypothesis is that the mean of A, B, and C are all equal, and the alternative is at least one is different than the others. We set an alpha. We calculate an F and a p-value by going under data analysis, ANOVA single factor, grabbing the data, and hitting OK. When you hit OK, you're going to get a new worksheet. I've already got the data right here. So I put the data right here. So the most important thing is the F statistic from the data and the p-value. Here's the F stat. Here's the p-value. Since the p-value is really small, we can reject the null hypothesis, which means at least one of these panels is different than the other two. Now that we have rejected the null hypothesis, we need to do post-ANOVA analysis to determine which is different than the others. I use confidence intervals. That's what I want you to use. There's other tests later on that you might learn, but we go back, and how we generate confidence intervals is that we need to be able to calculate the standard deviation, the sample size. The confidence level is an input. So this is an input, and then from this I can calculate the interval width, my confidence interval width. There's two ways, or several ways to do it. You could calculate T times S divided by the square root of N, or you can use this confidence formula, confidence.T. The first argument is alpha, which is 1 minus the confidence. The second argument is the standard deviation. The last one is the sample size. So I reference those numbers above, and I can get an interval width. Once I have the interval width, I can take the mean plus or minus this number. There's the plus, this is the minus, this is the mean for each of these. I'm going to go ahead and build a confidence interval chart, but how I do that in Excel, the trick way, is to use the stock chart. And you can see in this case the stock chart is called high-low close, high-low close, so you have to put it in that format. So the upper is the high, the low is the lower, and the close is the average. And this is the chart that we wind up with. And what we want to look for in this confidence interval chart is anything that there is no overlap. So in this case you can see panel C does not overlap with A and B, which means it's statistically different. In this case, it's statistically worse than either A and B. Because A and B overlap, I cannot say that B is better. I can say that A and B are statistically the same. There's no difference. So that becomes my final conclusion. From the confidence interval, C is different. That's what that should say, not difference. Different. Different than A and B are statistically the same. Okay, second problem. We're given some data, some survey data, and I want to know if cola preference is related to sweetness preference. The first thing I do is do a pivot table, and I come up with these results. When I build a pivot table, I drop cola into one field, sweetness in the other one. I do a count, and this is what I saw. So the null hypothesis is that cola and sweetness are independent. They're not related. and I try to prove that they are related. I try to prove that there is a relationship between the two. I set an alpha, then I go calculate a chi-squared. So how we calculate the chi-squared for this is once I have the pivot table, I copied everything down, and this is my observed data. Same numbers here, but there's no pivot table formula behind it. That's what I observed. This is what I expected. How I calculate an expected is take the row total times the column total divided by the overall total. For this one, it's the second row, second column, row total times the column total divided by the overall total. Once I have these numbers, I can now calculate part of my chi-squared, which is the observed minus the expected. Observed minus my expected, square that, divided by my expected. I get 6 terms, and if I add those up, I come up with my chi-squared number. So my chi-squared is the sum of those 6 numbers. Once I have those, I can calculate my p-value. P-value in Excel, I can use the chi test, C-H-I test. Grab the observed first and then the expected. Now make a decision based on the p-value. Since it's bigger than alpha, it's much bigger than alpha, then I fail to reject the null hypothesis. I'm going to don't have evidence to say otherwise. So if this is true, I don't have evidence otherwise, I'm going to say that there is no relationship between color and sweetness preference. They are independent. Okay, those are the 2 problems out of chapters 11 and 12. Thanks.